a very warm welcome to Arihant Online Academy, and here in this session we are going to discuss very important previous year's MCQs on greedy techniques. So the question number 1 is traveling salesman's problem TSP is an example of. So you all know that traveling salesman's problem, basically a traveling salesman is there and several cities are there, and suppose traveling salesman started from city A. The goal is to travel throughout all the cities one by one with the shortest path, with the shortest course, and the performance should be better. So it is a part of greedy algorithm. Option B is the correct answer. The next question is time complexity of fractional knapsack problem is. So in fractional knapsack problem, the first task is to sort. Sorting should be there, that which item we will pick at each step, right? So for that we do sorting there, and after sorting we add the items one by one. So total n items are there, and for sorting log n time will be taken. So total time will be order of n log n. Option A is the correct answer. The next question is, suppose the letters A, B, C, D, E, and F have probabilities 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32 and 1 by 32 respectively. What is the average length of Huffman code? Very important question, guys, and it is expected question for all CSIT exams like UGC NET, NIELIT, PGT, PGCET, and all important CS exams like ISRO and BARC as well, because it is asked in GATE CS, and the normal perspective of all other exam is that they may ask 4 to 5 questions of the GATE exam just without changing data from previous year. So focus on this. It is a Huffman coding problem in which we need to find the length of the code of each letter. So initially we are starting from here, and the letter A have a probability of 1 by 2. Okay, letter A have a probability of 1 by 2, then remaining probability is 1 by 2, and letter B have a probability of 1 by 4, remaining probability is 1 by 4 here, and letter C probability of 1 by 8, and 1 by 8 is remaining here now, and letter D have a probability of 1 by 16, and 1 by 16 is remaining here, and letter E and F have respectively 1 by 32 and 1 by 32 as their probability. Now what is the length of A? To reach A I just need to traverse only through one path. So the length of A would be calculated as 1 into 1 by 2, where 1 is the length from the root node and 1 by 2 is the probability. Plus what is the length of B? The path is 1 and 2. To reach here we need to travel up to 2 edges. So 2 multiply with its probability, that is 1 by 4. It is for A, it is for B. Similarly for C, I can write it 3 into 1 by 8, because 1, 2 and 3, isn't it? 1, 2, 3. For D, I need to travel 1, 2, 3 and 4. So for letter D, 4 into 1 by 16, plus for letter E, 5 into 1 by 32, and for letter F, similar 5 into 1 by 32, because for letter E 1, 2, 3, 4, 5, and for letter F 1, 2, 3, 4, 5. Now just calculate 1 into 1 by 2, that is 1 by 2, plus 2 into 1 by 4, that is 1 by 2, plus 3 by 8, plus 4 by 16 means 1 by 4, plus 5 by 32 into 5 by 32 means 2 into 5 by 32. So it is, I can just write it like 5 into 32 into 2, that is 5 by 16. Okay, 1 by 2 is there, 1 by 2 is there. So 1 by 2 plus 1 by 2 is 1, plus 1 by 4 0.35, plus 3 by 8 plus 0.35 plus 5 by 16. So after calculation you will get answer approximately 1.9. So option D is the correct answer. The next question is, which of the following are the operations performed by Kruskal's algorithm? So for Kruskal's algorithm, okay, let us scan the option. Let us scan the statements first. Sort the edges of G in increasing order by length. So in Kruskal's algorithm, we sort the edges of graph G. Suppose it is my graph. Then I will sort out that which edge is a smaller one and which edge have weight greater one, and on the basis of that I will keep sorting out the weight of each edge in increasing order, and I will add that edge in my subgraph one by one on the basis of lowest one first, and keep going until and unless I can't get any cycle. So keep a subgraph S of graph G initially empty, it is also correct. And third one is build a tree one vertex at a time. So there is not a building of tree one vertex at a time, because it is a condition in prim's algorithm. It is a point of prim's algorithm. In prim's algorithm, in the implementation of prim's algorithm, we do this. So only option in 1 and 2 is correct in regard of Kruskal's algorithm. So option A is the correct answer. The next question is, what is known as greedy algorithm because it chooses at each step the lowest edge to add to subgraph? So I just told you, it is a Kruskal's algorithm, just discussed in previous question. The next one is, what is the time complexity of Huffman coding? We have just performed Huffman coding. Total n elements are there, and to sort out n elements, log n step would be required. N log n, option B. The next one is, Dijkstra's algorithm is also called as single source shortest path problem. It is also called as single source shortest path problem. Option B is the correct answer. The next one is, the result of prim's algorithm is a total time bound of. So we need to perform time complexity of prim's algorithm. It is E plus V into log n to perform the sorting order of edges in E plus V, that is the time which will take by the number of edges and number of vertices. So here E and V are in the terms of m and n. So order of m plus n into log m is the time complexity, where you can consider m as edges, n as a vertex, or like that. You can consider according to yours, but option B is the correct. The next one is, which of the following standard algorithm is our greedy algorithm? Dijkstra's shortest path problem. Dijkstra's shortest path problem. It is a greedy algorithm. Prim's algorithm is also greedy algorithm. Kruskal's algorithm is also greedy algorithm, and Huffman coding is also greedy algorithm. So option A, B, C, D all are the examples of greedy algorithm. The next one is, the floyd-warshall all pair shortest path algorithm computes the shortest path between each pair of node in. So time complexity of floyd-warshall algorithm they are asking. Order of log n, order of n square, order of mn, or order of n cube. So you all know that it is very important part, that is floyd-warshall, and basically it is not in the syllabus of GATE computer science this year, but for all other exam there is not a particular syllabus, so you should know the answer. That is order of n cube. Order of n cube is the time complexity of floyd-warshall algorithm. Okay, just make a note of it. So guys, I hope all the questions which I have discussed with you are clear to you, and please guys subscribe our YouTube channel. If any kind of doubts or queries, ask us. I will try to solve them as early as possible. Have a very nice day guys. Don't forget to subscribe. Have a very nice day. Jai Hind, Jai Bharat.